dear student. This is Dr. 𝓂𝓫𝓫𝓬𝓻𝓲𝓫 from NKP Survey Institute of Medical Sciences, and today we are learning with the protein metabolism. As it's rightly said that need is the mother of an innovation, but sometimes need can be a mother of adaptation also. So let's adapt this new method of learning in this COVID COVID-19 lockdown period. And here we can maintain social distancing and we can continue our learning too. So let's start with the protein metabolism, and let me share the screen. Okay, so we'll start with metabolism, and this lecture is purely meant for first BDS students. So let's see what is in our syllabus. So according to MUHS syllabus, the protein metabolism should include digestion and absorption of protein, then some reactions like deamination and transamination, the importance of ammonia metabolism and urea formation will be taken. Few certain important reactions like transmethylation, formation of amines, and formation of phosphocreatine will also be dealt. Then introduction of other function, mostly aromatic amino acid functions, and one carbon transfer would be taken in subsequent lecture. So let's start with the first lecture and let's see some overview about the protein metabolism. As we know that proteins are very important to our body, as it has a structural tissue function role and it has a dynamic action also. And even you can see that in 70 kg man, every day around 300 to 400 gram of protein undergo degradation. That means whatever protein in our body, they're not static, but it undergo continuous degradation and resynthesis of cellular protein, and this is known as a protein turnover, and that's why we call that our body proteins are under dynamic condition. So let's see how does it happen. So every day around 1 to 2% of protein undergo degradation. And how does it happen? The most of this protein are tagged by the protein molecule which is known as a ubiquitin, and this ubiquitin tagged proteins are identified by a proteasome, that is the enzyme complex which degrades this protein. So once these proteins are degraded, it leads to the formation of amino acid. But as we all know that proteins are not a primary source of energy, so only 20 to 25% protein undergo catabolism and they are excreted in the form of urea, while 75 to 80% means major part is used. Major part of amino acid is used for resynthesis of body protein. So mostly it is like the whatever amount of body protein undergo degradation, equal amount is resynthesized every day. That's why protein undergo turnover. Now let's see what are the different phases of protein metabolism. Before in last slide we have seen that the dietary protein, around every day 50 to 75 gram of protein is consumed by a person, and the breakdown of tissue protein around 300 to 400 gram per day. So this catabolism of protein leads to the free amino acid in the blood, and this is known as an amino acid pool. Around 100 gram of pool is present, amino acids is present, and out of this mostly non-essential amino acids are available here, and 50% of them are glutamine and glutamic acid. So now how this amino acid from amino acid pool is utilized. So as in earlier slide we have seen, majority would be used for the synthesis of structural body protein like hemoglobin, synthesis of plasma protein, synthesis of enzyme, milk, and hormones also. Apart from this, major part is also utilized for the synthesis of non-protein nitrogenous compound. Actually, these are the specialized product which contain nitrogen, like hormones, choline, Then nucleotide like purine, coenzyme, niacin, serotonin, melatonin, they are neurotransmitter, even heme of hemoglobin, creatine, phospholipid, and few detoxification products are again synthesized from amino acid. As we all know that amino acid, the protein doesn't have any storage form, just like a carbohydrate is stored in the form of glycogen, fats are stored in the form of adipose tissue. Proteins are, they do not have any storage form. So more after the consumption of amino acid in the formation of uh, body protein and non-protein nitrogenous substance, the remaining part, it is catabolized to keto acid, and for this catabolism, two important reaction like transamination and deamination reaction happens, and then these amino acids are converted into keto acid. But out of this keto acid also, this keto acid again combines with ammonia. Actually, they are utilized to detoxify ammonia and leads to the formation of urea. And every day, around 15 to 30 gram of urea is excited in the urine. Now, remaining keto acids are either oxidized completely to form ATP, around 10 to 15% can be used in this way, and remaining ones are used for the synthesis of gluconeogenesis, and even there is a synthesis of non-essential amino acid. And remaining amino acid, which do not have role in any of this phase, they will be excreted in through the kidney, through the urine. So every day around zero point 0.9 to 1 gram per day amino acid is excited per day, I'm saying. And this is not, this cannot be tested by the routine test what we do for the detection of protein in urine. So these are the phases of protein metabolism. So from this table we can learn that the protein metabolism not only deals with the synthesis of structural body protein, but it deals with the synthesis of non-protein nitrogenous substance. Hence, even protein metabolism is also considered as a nitrogen metabolism. So, as we know that dietary proteins, they form tissue protein, and this tissue proteins are again used in the biosynthesis of protein by the continuous metabolic turnover, and remaining part of this uh, protein is excreted through the as a urea through the urine, then through the sweat and through the feces. So every day, the whatever nitrogen is nitrogen in